Good day, everyone. So today we're going to pick up with understanding measures of variability, more so how to calculate that in Excel. This will stem, it's more of a supplement to measures of central tendency. I'm going to give some in-depth steps to it, like if you were to calculate it by hand, and then show you the quick cut through or shortcut in Excel. The data that I have up here are for cities in the US, and I just pulled the percent living in the same household from a year ago. If you're not familiar with this data, I pulled it from the Census Quick Facts. Type in a certain city, the first one up here is Little Rock, and it gives you the ACS 5-year estimates. So for this one, I just pulled the 83% over into the chart. I did that for other cities as well. So this is where I obtained the data, just copied it over into an Excel spreadsheet to do an example. So remember, for the course, we're going over primarily range and standard deviation. We do touch on sample variance because it becomes important later in the semester when we cover other statistics that work from or utilize the variance. So let's get started. So if we start off, if you remember some of the other examples when we have the mean, so I'm going to just type these over here so you can see what I'm getting at. Mean, median. Given the levels of measurement here, we don't need the mode, it's not appropriate in terms of a statistic. So here, if we want the average, type average, highlight our range of values that we want to see what percentage is living in the same household over a year. Here we see the average percent of population living in the same household from a year ago is 81.85%. And then if we want the median, here again we have an even number of cities. So if we rearrange this from large to small or small to large, we'd have to take the two middle numbers and take the average of those. Luckily, Excel can do that for us. We don't have to rearrange. If you're not familiar though with how to rearrange, you can go through sort and filter and custom sort. And it's asking, it would pull these up, but if I pulled these and did a custom sort, has headings, and I want to sort by percent living in the same household, smallest to largest, it rearranges for me, and we see here number 4 and 5 in the middle, 80.7 and 82.6. So we took the average of those, and I'm doing this in a calculator, and I'll pull this over. So we did 80.7 plus 82.6, 163.6 divided by 2, and it just so happens that the median is the same as the mean. This is a good sign in terms of symmetric distribution. So now that we have those two for central tendency, now we're interested in the variability within the data set as a whole. With that, if we want to start with the range, keep in mind the range, we take the highest value and subtract the lowest value from that. So I'm going to create the formula in here. So it's going to be equals, and I always use parentheses, it's just out of habit. Since these were put into smallest to largest value when we sorted it, you know where to click for your largest value. It's in Newark, New Jersey at about 88%. And we're going to subtract the low value from that, Portland, Maine, not to be confused with Oregon. And we see that the range is 10. Here we know that the other values, we know the min-max. The part of the variability we don't know is the spread of the values within that range itself. This is what the standard deviation helps us with, and that's why I calculated the mean to start out with. So here, if you remember the steps of calculating the standard deviation, the first step is to subtract the mean from the actual values that we have. And to make it easier, I'm going to paste the formula for the standard deviation down here. So keep in mind, we're starting with the numerator here at the top. We want to have our values, subtract the mean from that. So from here, we're going to, I'm just going to type this out, 81.85. Oops, I did not need the negative sign there. And I'm just going to copy those values down. So here we have our mean. This is going to be our difference now. So if I take 77.9, subtract 81.85, hit enter, we now get the difference between those two values. Again, going to take that same formula, pull it down. The key part to remember here is we don't want to sum first. This is where we take the squared part. This helps us get rid of the negatives here, and then we'll sum after that. So I'm just going to write squared up here so I know where I'm at. And an easy way to do this is hit equals and times the cell before it, times itself, so you're squaring it again, and then copy those values down. I'm going to move this over just so we have 2 decimal places to work with. Now is when we can use the sum function. I'm going to keep it all at the top just to make it easier to follow. So sum, I'm going to hit equals sum, paren, highlight the values I want to sum, close that parentheses off, and we know the sum for this, the numerator of this equation is 63.54. The n, our sample size, remember we have 6 cities. So here n minus 1 to give us a more conservative estimate. We have 5, it would be our denominator. So if we now divide, it would be our sum divided by 5. Now we have 12.71 once we round that. For those familiar, this would be our sample of variance. It's in squared units. It's not as interpretable since it is in squared units. You have to discuss it that way. The key part here is then to take the square root to put it back into the original units. This would be percentage points that we can discuss. So here, I want the square root of the number here. And we can see, let me change this back to 2 decimal places, that the standard deviation is 3.56 percentage points. So we know if we take the 81.85 or 81.65, add the 3.56, we know that 85.21, and then if I pull up the calculator again, and I'm going to exit out, 81.85 minus 3.56, 78.29. Here's where between it's +1, -1 standard deviation around the mean. We know that 68% of our values would fall between 78.29 and 85.21% living in the same household from a year ago. So typically when you see a lower standard deviation, the data points are closer to the mean. The larger the standard deviation, the more variability within that, the farther they are from the mean itself. So this is an example of if you were doing this by hand. If you wanted to write it out, the steps for it's where you would calculate it by yourself. Another way to do it would be, I'm just going to type standard deviation. And in Excel, it gives you a couple different ones. I'm going to use standard EV, highlight the values, close it off. You can see here that, oops, wrong way. As a quality check, we can see that 3.56 is the same value we got up here with 3.56 when we did it the long way by hand. Excel does the quick way for you, makes your life a lot easier, but if you want to understand how it's calculating the difference and to see what a typical case is and then the variance from that, this is how you would do it if you were to do it by hand. Excel does it in one quick step, easy way to do it. If there's questions, please reach out to me. Cheers.